Hi, in section 11.2 we're going to talk about the concept of arithmetic sequences. And arithmetic sequences are a certain type of sequence, and what distinguishes them from other sequences is the terms all have a common difference from the term before them. Okay, so differences are of course found by subtraction. So what we're going to look at is a sub 2 minus a sub 1 will tell me the difference between the second term and the first term. And a sub 3 minus a sub 2 will tell me the difference between the third term and the second term. So likewise, a sub 4 minus a sub 3, this is how I'm going to find the common difference. So 4 minus 1 is 3. And 7 minus 4 is 3. And 10 minus 7 is 3. So you see that this number in each case is the same. That is an arithmetic difference. An arithmetic sequence, because they have a common difference. So you can see that this number is the same. Actually, let's get rid of that. So this number is the same in each case, and that is the common difference. So in this case, D is what we will call the common difference. D is equal to 3. And here if I do the same thing, I'll have negative 2 minus 2, that's equal to negative 4. I'll have negative 6 minus negative 2, that's equal to negative 4. I'll have negative 10 minus negative 6, that's equal to negative 4. So again, I have a common difference, and the difference D is equal to negative 4. Being able to identify D is very important because we use the common difference and the first term to be able to write the rule for the sequence. So an explicit rule, again, relates each term to its place in the sequence. So if a sub n is equal to 2n minus 1, I can find any term based on its place. So if I wanted to find, say, a sub 10, I know that would be equal to 2 times 10 minus 1, because for a sub 10, n was equal to 10. So this would be 20 minus 1, which would be 19. Okay, now we have a formula for writing the explicit rule for an arithmetic sequence. And it's always going to be a sub n is equal to a sub 1, the first term, plus the common difference, d, times n minus 1. So in this case, d was equal to 3. A sub 1, you can see, is 1. And so if I plug those into here, I have a sub n is equal to a sub 1, which is 1, plus my common difference, 3, times n minus 1. So this is 1 plus 3n minus 3, which is going to be 3n minus 2. And that's my explicit rule. In this particular case, a sub n will be equal to my first term, 2, plus my common difference, which is negative 4, times n minus 1. So this will be 2 plus negative 4n plus 4. Excuse me, I wrote x, but I meant n. 4n plus 4. So a sub n will be equal to negative 4n plus 6. Okay, if we wanted to check our rule to make sure it was right, you can see if I take 1 and plug it in for n to find a sub 1, negative 4 times 1 is negative 4, plus 6 is 2. It does work out to give me the same term. And likewise if I go through and check the other terms. If I want to find a specific term when I know the explicit rule, plug its place in the sequence, that's the n, into the explicit rule. So it would go wherever n is. So if I want to find the 9th term over here, I know that a sub 9 will be equal to 2 times 9 minus 7. Well, 18 minus 7 is 11. If I want to find the fifth term, a sub 5 will be equal to 2 times 5 minus 7, and 10 minus 7 is 3. So a sub 5 would be equal to 3. In this other rule, right, a sub n is equal to negative 3n plus 2, I do the same thing. A sub 4 would be equal to negative 3 times 4 plus 2. Negative 12 plus 2 is negative 10. And here a sub 7 will be equal to negative 3 times 7 plus 2. This is negative 21 plus 2 is equal to negative 19. So I can always find a specific term in a sequence by plugging its place in the sequence into my explicit rule in place of n. I can also use this equation to find the rule using any term and knowledge of the common difference. So in this particular case, they tell me that my common difference is negative 6, and the 12th term is negative 4. So if I write this out, I'll be able to find a sub 1, and if I have a sub 1 and the difference, I'll be able to write the rule. All right, so I know that a sub 12 over here, negative 4, was equal to a sub 1 plus my common difference, negative 6, times n, which was 12 again, minus 1. So if I simplify this, I'll know that negative 4 is equal to a sub 1 plus, well, 12 minus 1 is 11 times negative 6 is negative 66. So if I add 66 to either side of this equation, 66, or negative 4 plus 66 is going to be 62 is equal to a sub 1. Now if I know a sub 1 and the common difference, I know that a sub n is equal to 62 plus negative 6 times n minus 1. So a sub n will be equal to 62 plus negative 6n plus 6. So my rule here is a sub n is equal to negative 6n plus 68. If I want to find the sum of an arithmetic series, I can use this formula. The sum of n terms will be equal to n times the average between the first term, a sub 1, and the nth term, a sub n. So in order to use this formula, I need to know how many terms am I finding the sum of. I need to know the first term, and I need to have the nth term. And I can always find the first term or the nth term by using the explicit rule. If you remember when we talked about summation notation, this is telling me to start at the first term, go to the 8th term, and find the sum of those 8 terms from the sequence that has this rule. So I know that the sum of 8 terms will be equal to 8 times a sub 1 plus a sub 8, all divided by 2. Okay, so you can see that the n got used in 2 places here. I have a sub 1 and I have a sub n. Okay, now in order to do this, of course, I need a sub 1 and I need a sub n. Well, remember, I can use the rule to find that. I know that a sub 1 was equal to 2 times 1 minus 6. Well, 2 minus 6 is negative 4. And I know that a sub 8 would be equal to 2 times 8 minus 6. 2 times 8 is 16. 16 minus 6 is 10. So when I sub that in, the sum of the first 8 terms is going to be 8 times negative 4 plus 10 divided by 2. Well, negative 4 plus 10 is 6. 6 divided by 2 is 3. So this is 8 times 3, which is equal to 24. Okay, remember, we used our n. We used a sub 1. And we used a sub n. Okay, let's do another problem like that. I want to find the sum of my first 16 terms. Okay, so I know that the sum, excuse me. So I know that the sum of 16 terms will be equal to 16 times a sub 1 plus a sub 16 divided by 2. So a sub 1 would be equal to 5 times 1 minus 7. That's equal to negative 2. And a sub 16 is going to be 5 times 16 minus 7. So this is going to be 80 minus 7 is 73. Okay. When I pop these in here, the sum of 16 terms is going to be 16 times negative 2 plus 73 divided by 2, okay, which is going to be 16 times 71 halves. 2 will cancel with the 16 and leave 8. And 8 times 71 is going to be 568 for the sum of 16 terms. Okay, so in 11.2, what we learned to do was write the rules of arithmetic sequences by finding the common difference and using the common difference and the first term, and also to find the sum of an arithmetic series. Remember, a series, again, is a specific number of terms from a sequence. Okay, and we find the sum of those terms when we're using summation notation.